All right, so now we're on the second page of investigation B, and we're going to solve the problems in number 4 right here. So one thing to note is that when we try to solve this problem right here, where it asks for the sine of pi over 4 radians, we just need to note that sine is talking about the y-coordinate. So that's important to keep in mind. If you just use the y-coordinate, you can get the answer to this question. And it's the y-coordinate at which point? It's the y-coordinate at the angle pi over 4. But we can also use the triangle that we have. So the sine of pi over 4, well, 45 degrees or pi over 4 is the same angle. So the opposite side, the opposite leg right here, is rad 2 over 2. So sine, remember, is opposite. So rad 2 over 2 divided by the hypotenuse's length. And the hypotenuse's length is 1. So rad 2 over 2 over 1 is just equal to rad 2 over 2. Anything divided by 1 is itself. So this is your answer. I can't seem to... There we go. Circle drawing contest needs a little bit of work. All right, next one, we look at cosine. We're going to do this problem just a little bit differently. What we introduced at the beginning of this investigation is the cosine of theta, or the cosine of any angle, is always the x-coordinate at the angle. The x-coordinate at the angle. So for 3 pi over 4, let's look at the angle 3 pi over 4. So 3 pi over 4 is this angle right here. It's this angle. So we're actually talking about the coordinates at this point right here. And which coordinate do we want? Well, we're dealing with cosine. So cosine is our x-coordinate. The x-coordinate at this point is negative rad 2 over 2. And that makes sense because we learned in that acronym all students take classes that sine is the only trig function that's positive in the second quadrant. And that explains why our cosine value is negative, because we're in the second quadrant with 3 pi over 4 and we're dealing with cosine, so we're dealing with a negative angle. And so that's our answer for question B. Now, just remember that in this third one, we're looking at tangent. And just to review that x is cosine of theta and y is the sine of theta. Well, tangent is the opposite leg divided by the adjacent leg. So tangent actually always is going to be y divided by x. That's tangent right there. So if we look at negative 5 pi over 4, that's going to be, let's find that angle. Well, negative 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. That's negative 5 pi over 4. So we could say that this angle that we already marked is also negative 5 pi over 4. So we're going to be using the coordinates of this point right there to get our tangent value. And we said that the tangent of any angle is the y-coordinate at that angle. So in this case, the y-coordinate is going to be this right here, rad 2 over 2, divided by the x-coordinate at the angle. And the x-coordinate at that angle, negative 5 pi over 4, is that negative rad 2 over 2. Well, we essentially have one number divided by itself, except one of them's negative. So we know the answer is going to be -1, but let's show the work. So we have rad 2 over 2. Whenever we divide by a fraction, we end up multiplying by its reciprocal. So that means we're going to multiply by the reciprocal of the denominator. So that'll be -2 over rad 2. And what's going to happen here when we actually multiply numerators by numerators, we'll see what happens. Or we can cross cancel. Rad 2 over rad 2 cancels to 1. And 2 and 2 also cancel. So we're essentially multiplying 1 by -1. And you get -1 over 1 times 1, which is 1. And our final answer is -1. And so that's how we use the reference angles and coordinates on the unit circle to help us answer specific calculations for trig functions. Thanks for watching.